We're looking at a unit on factoring, and before we get started into trinomial factoring, we first need to take a look at something called the greatest common factor. Now, we've done greatest common factor in the past with just numbers, but now we're also looking for letters. And so what we're going to look at here is just trying to find out what is the biggest number they can both be divided by, and what is the biggest number of x's that they have. So for this one, I can say, well, they both can be divided by 6. This can be divided by 12, but this can't. So I can't say 12. So 6. Now you can actually, I think you can do this a different way as well. You can go 9 times 2. This one could be 8 times 3. 9 is going to be 3 times 3 times 2. And here is going to be 8 is 2, 2, and 2, and an additional 3 can be brought down. So you can take a look at this. So there's a 3 and a 2 in common, and a 3 and a 2 in common, which is 6. So that is one way you could do that, but generally we just kind of look at these things and say what's the biggest number that they can be divided by. So the biggest number is going to be 6, and the biggest variables they have in common, well, this has 1 and this has 4, so they both share at least 1. So we say 6x is the greatest common factor. So then we have 63 and 42. Again, you could do this. This is 9 times 7. This is 3 times 3 times 7. 42 is going to be 7 times 6. And 7 times 3 times 2. And so if you take a look at these, they both have a 7 and a 3. 7 and a 3, which is 21. So these both can be divided by 21. So I'm just going to write that down here. 21. They both have an x to the 1, which is nice, okay. And y3 and y2, well, they both have a y2. So the smallest that they have, that they share, is a y2. Well, it's actually the biggest. They share a y1. But y2 is the biggest y that is shared. Okay, so take a look here. 30 and 48. So again, you can, if you want to, you can go 6 times 5, 3 times 2 times 5. 48 is 12 times 4. 12 is going to be a 4 and a 3, and this 4 will be a 2 and a 2. So this is called prime factorization. We've probably done this already. And so a 3 and a 2 is a 6, and a 3 and a 2 is 6. That's what they share in common. So 6. So these can both be divided by 6. And x5 and x3, so the smallest is x3, so they both have an x3 that can come out. y2 and y3, y2 is the smallest, and so y2 can come out of both of them. So that is the GCF of those two things, those two terms. 32 and 40, again, you can do the tree, but I know that 8 is it. So 8 would be the greatest number that they can both be divided by. x5, x2. x2 is the biggest number between both of them, so they both have an x2. y2 and y2, the biggest number between them is a y2. They both have a y2 that can come out. And z2, z5, so a z squared is the smallest number between them, so they both can have a z squared come out. Now, there is some things to think about negatives. So when we actually do this, if the very first term has a negative, we'll actually factor a negative out. But for all of these ones, they're not a polynomial. They're just two different terms separated by a comma. But when things have plus and minus signs in between, if the first one has a negative, we'll actually divide them both by a negative. Okay, so let's switch from these monomials with commas into polynomials. So here we need to, it says common factor the following polynomial. So we need to find out what is the GCF of this. So sometimes it's nice to write it off to the side here. So the number that these both can be divided by is a 4, and they both have at least an x to the 1. X to the 1 is the smallest between them, so they both have a 4x. So how to do this? Well, you basically divide both of these by the GCF, and you write that GCF out in front. So we'll write the GCF out in front, and then we'll have some brackets here. Now 8 divided by 4 is 2, and x squared and an x1, 2 minus the 1 that's there is just going to be a 1. Plus 20 divided by 4 is 5, and there's an x and an x, they both are x to the 1s, those will just cancel out. So this is it. I have factored it. Now, factoring means turn something into multiply. So right now, this thing was 8x squared plus 20x. That was something that was being added. It was a polynomial. But now I've turned it right here into 4x times 2x plus 5. So I've turned it to something that is predominantly a multiplication. So there should be a multiply sign here, which we don't do. We just leave the x in between. Or sorry, we just leave the brackets. So we have, if we've turned it to a multiply, that means we've considered it factored. However, we usually don't write the brackets around the whatever term we take out at the front term there. So that is considered factored. So you find the GCF here. So the GCF was 4x, and then you divide both of those by 4x. And you can put the 4x out in front, and then you can do some simplification. So working backwards, which we're not going to do, but I'll just show it to you. If you were to multiply this in, you get an 8x squared, and that 4 times 5 is a 20 with an additional x. 8x squared plus 20x. And that should be our original, yep, 8x squared plus 20x. So that's how you know you've done it right. If you actually did the multiplication, you would see that it lines up with the original. Okay, so I did a lot of talking, but let's just try another one. So we need to figure out what is the GCF. What can these both be divided by? Well, they both can be divided by 4. This has an x to the 1 and an x2, so the x to the 1 is the smallest. y2, y1, so a y1 is the smallest. So this is the GCF. Now I did just say previously that if the first term has a negative, we are not a rule, it's a convention. So it's not necessarily a rule where it's exactly like that, but the convention is what we usually do is take out a negative. So I'm going to put that negative there because the first term has the negative. So how do we do this? Well, we write the negative 4xy out in front, and we're going to have a couple things there. And let's now divide by this negative 4xy. Negative 4xy. Now, negative 16 divided by negative 4 is 4. There's 1x and 1x, those will cancel. There's 2 y's on top, 1 on the bottom, so there's going to be 1 left over on top. Now, 12 divided by negative 4 is a negative 3. There's 2 x's on top, 1 on the bottom, so we'll just have an x. And then y's 1 on each, so those will cancel out. So this is considered factored. We've taken out the greatest common factor. Okay, let's take a look at the next one here. So we got this GCF. I see the first one has a negative, so I'll take out a negative. And 3 can come out of both of these. Now, x2, x3, the smallest is x2. y2, y3, the smallest is y2. So that's our GCF. So I will write that down on front, negative 3x squared y squared, and we'll multiply it in here. Now let's actually divide this, negative 3x squared y squared, negative 3x squared y squared. So negative 3 divided by negative 3 is 1. 2x's on top, 2x's on the bottom, those will cancel. 2y's on top, 2y's on bottom, also cancel. So I'm done with that, it's just a 1. Negative 9 divided by negative 3 is going to be a positive 3. 3 on top, 2 on bottom, that'll leave me with just an x. 3 on top, 2 on bottom, that'll leave me with just a y. So that is my final answer. I've factored out the greatest common factor. Okay. Now, let's see, I see the first one starts with a negative, so I'll take out a negative for my GCF here. And they can both be divided by 10. X and x2, the smallest is x. y2 and y2, the smallest is y2. z2 and none, the smallest is none. So I won't actually do that. There's no z's that they have in common, so I'll just divide this by the negative 10 xy squared, negative 10 x and y squared. So I start by writing that up front, negative 10 xy squared, and then I can write what I have left over. So that'll be 10. So negative 10 over negative 10 is just a 1. 1x and 1x cancel out. y2, those also cancel out, so I'm just left with a z squared. And negative 4 divided by negative 40 divided by negative 10 is positive 4. 2 x's on top, 1 x on bottom, so it leaves me just an x on top. y2 on top, y2 on bottom, those will just cancel out. So this is my final answer. I've taken out the greatest common factor. So in the next video, we'll do some more of that, and then we can get into some factoring. So I'll just zoom out here in case anything needs to be looked at, but I'm sure the answer key will show everything, so you can just look at that if you need to.